Welcome and thank you for watching the webcast about budget constraints. First, we will discuss some theory. After that, we will do some exercises. First, what is a budget constraint? A budget constraint is the representation of all possible combinations between two goods a consumer can buy, given current prices and while fully exhausting its income. As the definition teaches us, a budget constraint is made regarding two goods. Let's name them X and Y. X and Y can, for example, be X being pears and Y being apples. We can also look at X being pears and Y equals all other goods that the consumer can buy within its budget. A budget constraint takes the costs of both X and Y in account. The budget line represents all possible combinations of goods that fully exhaust the consumer's income. This combination of goods is called a bundle. The function of a budget constraint will then be the following: the price of X times the amount of good X plus the price of Y times the amount of good Y. This equals the income that we call M. There will be an exercise later on. When we draw a budget constraint, we know that every bundle on the budget line is an affordable bundle. Everything that is above the line is not affordable. All bundles that are situated under the line are all affordable bundles. However, they do not fully exhaust the total income. We say these bundles are not efficient.
So now that we've seen the theory of the budget constraint, we will now look at some examples of how you can use the budget constraint and how to calculate it. So first we're going to look at an example of how to compose the formula of the budget constraint and then draw the graph that goes with it. So for this example, we will use cheesecake and ice cream as the two goods that we're comparing to each other. We'll take for the price of cheesecake as 3 and the price of ice cream in this example will be 2 euros. And then the income of our particular subject in the example is 12. So let's see at how we make the formula. Remember how the standard formula is Px times X plus the price of Y times the amount of Y is equal to the income. So if we fill this in, then the price of X, which we can say is cheesecake, is 3. And then we don't know how much of X, so we'll just use X. And then plus the price of Y, which is 2, which we will do times the amount of Y, which we also don't know, and then equals 12, which is our income. So this is the formula of the budget constraint in this particular situation. Now to draw the graph, we need to find out where this graph starts and ends. So we will fill in 0 for X and then 0 for Y. So for X is 0, it's 3 times 0 plus 2y is 12, which is 2y equals 12, meaning that I is 6. So we know that at the point of x is 0, y is 6. So let's see. So x was cheesecake and y is ice cream, which is right here. And then we'll do the same for y is 0. So if y is 0, we will get 3x plus 2 times 0 is 12, which is 3x equals 12, meaning that x is 4. So at this point, we now know that where ice cream is 0, cheesecake will be 4. So right there. And then we will simply draw a graph from this point to that point. So this is the graph of the budget constraint in this particular situation. So as we can see with the budget constraint, and we learned earlier during the theory, everything above this line, so everything on this side, is not affordable. And everything on the inside you can afford. So you could choose to buy 2 ice cream and 2 cheesecake. But there's no need to do that because you still have income left over. You could buy, for example, 2 ice cream and 3 cheesecake, and then you'll have more cheesecake, which is generally assumed to be better. So we try to always find a bundle on this line because it's the most efficient bundle that we can find. So now that we've seen this as an example about graphing the budget constraint, we will now look at what happens if we change the income. So for this next example, we will change the income from 12 to 15. And then we'll do the graph again. So we have the price of X, which is 3 times X, plus the price of Y, which is 2 times Y, equals our income, which is in this case 15. Now that we have this, we will look at what happens if we put in 0. So if we put in 0 for X, then as we saw earlier, we have 2Y is 15 because 3 times 0 is 0, meaning that Y is 7.5. And if we do the same thing for plugging in 0 for Y, means that we get 3x plus 0 equals 15. And then x equals 5. So if we look at this, for the y, x is 0 and y is 7.5, then that is right here. And if our ice cream is 0, then our cheesecake will be 5, which is right here. And then we can graph this new graph. You can see that these two graphs are parallel. So the slope of these graphs is the same in both graphs. This is because the prices of the goods did not change, only the income. So if income increases, then the graph will move further to the outside because you can now afford more of all the goods that are in this area. And likewise, if your income decreases, it will move inwards. So I cleaned up our page a little bit because next we're going to look at an example of what happens if we change the price. So for this example, we're going to look at what happens if we have a price of $2.50. So we still have x is 3, so the price of x is 3 times the amount of x, which will be x. And then the price of y, which is now $2.50, times y, so the amount of y, equals our income, which is 15. This is our new graph. So let's look again. We'll plug in 0 for 3, so that's 3 times 0 comes to 0. So that's 250y equals 15, and then y will equal 6. Alright, and then if we put in y as 0, then we'll have 3x plus 250 times 0 is 0 equals 15, which makes x equal to 5. So we now know that our new graph will be at x is 0 and y is 6, so 0 cheesecakes and 6 ice cream, which is this same point. And then our x equals 5 if y equals 0, and then we'll draw the graph between these 2 points. So that would be our line. And as you can see, this line, the slope now changed. So compared to the other lines, our slope is steeper. And this is what happens if the price of any good changes.
If you are interested in other related subjects, you can check out indifference curves, optimization with budget constraint, and substitutes and complements. Thank you for watching.